Hello and welcome back to another fun and exciting adventures in geometry. Today we're talking about measuring angles, section 1-4 in your book. Starts on page 27. Our essential learning is that you can use number operations to find and compare angles. So let's start by looking at some of our vocabulary that we're going to be talking about. Vocabulary in this lesson is to draw pictures or look at the pictures. So what I've got here is an angle. So an angle is simply a figure formed by two rays that have the same endpoint. So here's one ray, two rays. The sides of the angles are the rays that make up the angle, and the vertex is the point where they intersect. When talking about the measure of an angle, the measure of an angle is the amount of opening. And the measure of this particular angle is about 45 degrees, and we'll talk later about how to measure angles. Now we have what's called the exterior of an angle and the interior of an angle. The exterior of an angle is classified as the area on the outside of an angle. So basically all this would be considered the exterior of the angle. Whereas the interior of the angle is usually the smaller area inside. So that's the interior of the angle. And if you were to extend these rays out farther, then the interior of the angle is still going to be all this area. Postulate 1-7 is called the protractor postulate. And it basically says that any angle can be assigned to an angle measurement. The angle measurements are going to be from 0 degrees to 360 degrees, although we will usually be looking at just angles from 0 to 180 degrees. Let's go ahead and look at a quick example of how to use the protractor in case any of you have forgotten. So here we go. To measure an angle, at this point at the vertex, the little hole there, line up a line here, and then we can take our measurement in here, and since we're on this small angle, we're reading on the inside, and this angle is about 35 degrees. Similarly, there's another example. Measuring angle PQR. Again, we're going to line up our protractor as such. And now we're going to read the angle of measurement over here, but now we're on the large side, so we're going to be a measure of about 145 degrees. We can quickly look at the different types of angles. We have acute angles. Acute angles are angles that are less than 90 degrees, from 0 to 90 degrees. Right angles are angles that are exactly equal to 90 degrees. Obtuse angles are larger than right angles. They're from 90 degrees all the way to 180 degrees, but not at 180 degrees. Once we get to 180 degrees, we have what's called a straight angle, which looks like a line. Why don't you go ahead and pause the video and see if you can determine the angle measurements of the following angles listed, and when you write them down, make sure you use correct notation. I'll put the answers up in just a few seconds. So for the following angles, angle HKL, you say the measure of angle HKL is 35 degrees. That's right here. And notice we do use the M to talk about using measurement. When we talk about the measurement of angles, we have to put the M there. and the angle symbol. HKL is 90 degrees. Now when we look at angle LKJ, LKJ is this angle in here, so really it's the 90 degrees minus 35 degrees. 90 minus 35, which would be 55 degrees. LKM, that's this angle in here, is going to be, if we go this way, it's going to be 145 degrees. And we're going to subtract out 35 degrees, and we end up with 110 degrees. And measure of angle HKN, HKN is this straight line. The straight line is 180 degrees. When we talk about notation, let's talk about congruent angles. If we were to look back up here at angle, let's say angle NKM, the measure of angle NKM is equal to 35 degrees. Notice that's the same measurement as angle HKL. They're both 35 degrees. So we could say that those are congruent angles. So congruent angles, we use the notation, we just state the name of the angles. Angle HKL is congruent to angle NKM. Notice when we're talking about congruence, we're not saying anything about the measures of the angles. The congruent symbol just means that the angles have the same measurement. In the last section, we talked about what was called the segment addition postulate, which simply said that we could add two parts of a segment together to equal the total length of a segment. This section, postulate 1-8, we have something very similar called the angle addition postulate. And likewise, the angle addition postulate simply means that if we have an angle, the sum of the measure of its parts is going to equal to the total angle measurement. And so we can use that to help us solve problems. Let's look at an example. Let's move this out and move this up here. So here's the first example. And what's not listed here on this problem, but is given in the original problem, is that the measure of angle RQT is equal to 155 degrees. So let's add that. The measure of angle RQT is equal to 155 degrees. So that's RQ, I guess it's ROT. We can fix that, or we can just make this, how's this? We'll make this a Q. There we go. So the measure of RQT is equal to 155 degrees. That means this total measure is 155 degrees. So therefore, we should be able to add angle RQS and angle SQT together, add these two expressions together, and set them equal to 155 degrees. So we get this expression here, or the equation, 4x minus 20 plus 3x plus 14 is equal to 155. And we can then solve that. Solving for x would lead us to x is equal to 23. Once we have the value of x, we can substitute x back in to these expressions to find the individual angle measurements. One more problem we can look at is this one. And in this case, this DEF is supposed to be a straight line. And so when we add these two measurements together, they should equal to 180 degrees. So 180 degrees, that's the measure of angle DEF. So therefore, to solve this equation, we could just do this. LX minus 12 plus 2x minus 10 is going to equal to 180 degrees. So there's the equation that we would want to solve. And if we solve that for x, we would get x is equal to, x is equal to 14. Why don't you go ahead and try these problems on your own for tomorrow? And remember, there may be a short quiz over this section, including these problems and any of the material we've talked about. Thanks for listening.